All right, guys, continuing on with section 4 of chapter 1 called the distributive property. So last time we talked about the associative and commutative properties. Now we're going to talk about what's called the distributive property, and we're going to use that to evaluate expressions, and we're going to use the distributive property to simplify expressions. So we're going to talk about things called like terms, something called simplest form, and a thing called the coefficient. So we'll explore all that in a minute. So John burns approximately 420 calories per hour by inline skating. The chart below shows the time he spent inline skating in 1 week. To determine the total number of calories that he burned inline skating that week, you can use the distributive property. So there are two methods you could use to calculate the number of calories John burned inline skating. You could find the total time he spent inline skating, then multiply the calories burned per hour, or you could find the number of calories burned each day, then add to find the total. So if I did the rate times the total time, I would have to do 420 times all the times added up together first. So if I add up all those times, that ends up being 7 hours. So 420 times 7 is 2,940. Or I could figure out how many calories he burned every day and then add those together. In other words, multiply the 420 times each number of hours for each day, and then add those values up, and it's the same problem, you just did it different ways. You should get 2,940. Now I'm thinking method 1 is going to be a lot easier because it's easier to add these numbers and then multiply by the 421 time, rather than multiply by the 420 each time and then still have to add up all those numbers. So either method gives the same total of 2,940 calories burned, and that's an example of how we use the distributive property. So the distributive property, I like to think of the word distribute. Whenever you deal cards, you distribute cards. So whenever you deal cards, I'm just relating this to real life, the dealer gives a card to each person in the game. Well, the distributive property, when you're multiplying a number times a set of parentheses, the number gets distributed or dealt to each number inside the parentheses. So if you have 3 times the quantity 2 plus 5, you distribute the 3 into the parentheses times the 2 and the 5. So 3 times 2 plus 3 times 5. Okay, now this one is an easy example because you could just add the 2 and the 5 and get 7 multiplied by 3 and get 21. But to illustrate the distributive property, you distribute the 3 and get 3 times 2 plus 3 times 5, which is 6 plus 15, or 21. Same answer. And it still works with subtraction. Okay? But again, we're illustrating it with numbers so that when we get to algebraic expressions, you know how to work it here. So the symmetric property of equality allows the distributive property to be written as follows. So if A times B plus C equals A times B plus A times C, then A times B plus A times C equals A times the quantity B plus C. So it's like you could use the distributive property forward and backward. You can like undistribute the A if it's in each term. So a group of 7 adults and 6 children are going to the University of South Florida Bulls baseball game. Use the distributive property to write and evaluate an expression for the total ticket cost. So you need to find the total cost of each ticket and then find the total cost. So an adult single game is $5. Children's single game is $3. Groups of 10 or more are $2 per ticket, and a senior single game is $65. So there are 7 plus 6 or 13 people are going to the game, so the tickets are going to be $2 each. So write an expression that shows the product of the cost of each ticket and the sum of adult tickets and children's tickets. So 2 times 7 plus 6 is the same as 2 times 7 plus 2 times 6, or 14 plus 12, or 26. So the total cost is 26. You could check that by just doing 2 times 13, which is 26 also. Why didn't we use these other numbers? Well, that's because if you have 7 adults and 6 children, you have 10 or more people. And if you have 10 or more people, it doesn't matter if they're adults, children, or seniors. It's still going to be cheaper because it's only $2 per person. All right. Here's one for you to try. Go ahead and pause the video. All right, we're back. A group of 3 adults, an 11-year-old, and 2 children under 10 years old are going to a baseball game. write and evaluate an expression to determine the cost of the tickets for the group. So in this case, I have 3, 4, 5, I have 6 people. So I'm not going to get the 10 or more group rate. So if I have 3 adults, that's going to be $5 times the 3 people, plus an 11-year-old and 2 children under 10. But remember, the children's rate is for kids 12 and under. So I'm going to do 3 times 2 plus 1. See the little trick they put in there? You have an 11-year-old and then 2 children under 10. But the children's rate is for anybody 12 and under. So really, you're getting the children's rate for all of those. Okay, so that's going to equal 15 plus, if I distribute here, I get 6 plus 3, which ends up giving me $24. Okay, so the total cost is $24 for those people. All right, cool. You can use the distributive property to make mental math easier. So check this one out. So let's use the distributive property to rewrite 7 times 49, then evaluate. So remember, 49 is really close to 50. If you can get your number to an even group of tens or hundreds, it's going to be a lot easier. So if you think of 7 times 49 as 49 groups of 7, you're really going to, it's easier if you do 50 groups of 7 minus 1 group of 7. So if you think of it as 7 times 50 minus 1, then you could do 7 times 50, which really you could think of that as 7 times 5 is 35, so 7 times 50 is 350, minus that 1 extra group of 7 that you use to make it 50 instead of 49 groups, okay? So 350 minus 7 is 343. Now, I know I wrote this down, but this is how you can think about it in your head to mentally multiply 7 times 49. If it was 7 times 48, you could write it as 7 times 50 minus 2. And then that would be 7 times 50 minus 7 times 2. So 350 minus 14, which is 336. Okay, see, it doesn't have to be just 1 off. It can be 2 off, 5 off, whatever, you know. All right, so let's use the distributive property to write each expression and then evaluate it. Go ahead and pause the video. All right, so 304, think of that as 300 plus 4 times 15. And then when you distribute it, you get 300 times 15 plus 4 times 15. 300 times 15. So think of it, 3 times 15 is 45, and then add your 2 zeros. 0, and 4 times 15. Well, 15 and 15 is 30. That's 2 15, so 2 more give you 30 more, so that's 60. So there'd be 4560 is the total there. Okay? So 2b you could think is 44 times 2 plus 1/2. So 44 times 2 plus 44 times 1/2. So that'd be 88 plus 22, which is 110. Right, 210 times 5, you could think of that as 200 plus 10 times 5. So that'd be 200 times 5 plus 10 times 5. 200 times 5, think 2 times 5 is 10. So 200 times 5 is going to have 2 zeros on it. So that's 1,000. 10 times 5 is 50. So you get 1,050 for that one. All right, and the last one. I think it's going to be easier to break the 52 up into 50 and 2 rather than do 10 and 7. Okay? Usually whichever one, if it's a problem that's similar to this where neither one of them end in a 0, whichever one is closer to a multiple of 10 or a multiple of 100, use that one and break that one up. So you would do 50 plus 2 times 17. Okay, so it'd be 50 times 17 plus 2 times 17. All right. So the 2 times 17 is 34. And 50 times 17. You think 5 times 17, which is 85. Add a 0, so it'll be 850. So that's going to be 884 for the total there. Okie dokie. All right. So that's it for this video. Please stay tuned. In the next one, we're going to talk about how to simplify expressions. See you there.